Hey guys, I'm going to do a bunch of examples for us right now, going over solving trig equations. So when you solve trig equations, you really want to pay attention to the directions. Are they looking for a general solution? Are they looking for solutions between certain set values? Are they looking for solutions that are in radians or degrees? So the directions will usually give you some hints as to what they're looking for. Here, the directions I have for us are solve such that theta is between 0 and 2 pi, 0 included and 2 pi is not included. Some people just read this off as 0 is less than or equal to theta, which is less than 2 pi. That's also fine. This is inequality notation. You may also see it written in interval notation, which would look like this, a 0 that has a bracket, which implies it's included, 2 pi with a parenthesis. So on this interval. Since my interval that I'm asking for is given in radians, my answers should also be given in radians. Since I have a set space that I'm looking for answers between, I'm probably going to have a finite or limited number of answers. When you have a periodic function like cosine or sine or any of the trig functions, that is being solved on an open interval from negative infinity to infinity, looking for all solutions. Well, you're going to have an infinite number of solutions because it's periodic. It repeats itself. Anyhow, let's go ahead and work through this. What we're going to do is apply inverse operations to isolate theta. Theta is your variable, and you want to get theta alone. So the first thing I'm going to do is I'm going to combine some like terms, and I'm going to bring things to the right that don't have any theta involved, and I'm going to bring things to the left that do have theta involved. I'm subtracting root 3 from both sides, and I am adding cosine theta to both sides. That means on the right, I have negative root 3. On the left, be careful, that's not cosine squared theta. That is 2 cosine theta. When you add the coefficient out front of the like term, like radical, like trig, whatever it might be. And when you multiply is when you see the degree increase. Now from here, we're still on our way to isolating theta. Since 2 is attached to cosine theta with multiplication, I'm going to divide both sides by 2. This 2 right there, we don't call that canceling. Canceling is what happened here. This here is either called simplifying or reducing. It becomes a 1. Canceling becomes a 0. Next step, I'm left with the cosine of theta equals negative root 3 over 2. Now, there's a number of ways that you can go about finishing up this problem. Some people are pretty visual and know the unit circle by heart, and they're just going to do it that way. But either way, whether you do it this way or we apply trig inverse, you still read it off asking yourself a question. The question you ask yourself is the cosine of what angle or angles is equal to the ratio. Remember, trig is ratios. The ratio of negative square root 3 over 2. So what we're looking for are the angles. Theta is representing unknown angle or angles. And cosine's ratio, the ratio of cosine, which is negative root 3 over 2, is adjacent over hypotenuse. It doesn't mean it's exactly those numbers. It just means that the ratio reduces down to those numbers. Now, if you're a visual person, you know that cosine is related to the x-axis. If it's negative, then negative 1 is way out there, negative 1/2, negative root 2 over 2, negative root 3 over 2. On the unit circle, which angles correspond to the negative square root of 3 over 2? Those two angles are 5 pi over 6 and 7 pi over 6. Now, they're not always going to be unit circle angles, so you may need to use a calculator and an additional step. So I'll show you what that other step would look like if this wasn't something we would find on the unit circle. When you want to get that theta alone, people tell me lots of crazy things when I ask for participation on something like this. Divide by cosine. You cannot divide by cosine. Cosine is, it's just like saying divide by the square root symbol. Divide by the word log. Like, you can't divide by the function operation. It's just an operation, you know? So we have to apply what we've been doing. We've been applying inverse operations. The inverse of cosine is, simply put, cosine inverse. It's not negative cosine. It's not 1 over cosine. It's not secant. It's not sine. All right? Cosine and sine are what we call cofunctions. Secant and cosine are reciprocals of each other. Cosine inverse, this is not cosine to the negative first power where it would be 1 over cosine. Context matters. This is cosine inverse, sometimes written as arc cosine, A-R-C-C-O-S. Your calculator probably has it like that. These are gonzo. You're left with theta. And then you also are left with that. This is a lesson for another day. Your calculator is a function tool. It will give you one answer. Your calculator will give you an answer for a negative ratio in quadrant 2. Again, this is not for today. And then it would be up to you to figure out the reference angle and then use the reference angle to figure out the other angle or angles according to whatever the directions are asking you. But that's just a little side information for future lesson. Really here, you'd be done at this step because those are the only 2 answers to this question. I hope that helps you understand this type of example, but they definitely get a little bit more intense than this.